Hi everyone, in this video we're going to be solving AQA GCSE Chemistry Foundation Tier Paper 2, June 2020. In this particular paper we're going to be solving from question number 1 to question number 5. This is the part 1 of the video. Please subscribe for the part 2 of the video. This question is about ammonia and fertilizers. Ammonia is produced from nitrogen and hydrogen. A catalyst is used to speed up the reaction. The word equation for the reaction is nitrogen plus hydrogen producing ammonia. What does the symbol show about the reaction? This symbol shows that the reaction is reversible. Which catalyst is used when ammonia is produced from nitrogen and hydrogen? When ammonia is produced from nitrogen and hydrogen, we can use the catalyst iron. Iron is a transition element, alright? It belongs in the D block of the periodic table, and most of the elements in that particular block basically acts as catalyst. However, chlorine and oxygen are gases, so we can easily say that they are not the catalyst. Figure 1 shows the reaction profile for the production of ammonia both with a catalyst and without a catalyst. We can see the problems of the reaction energy. We can see with a catalyst and without a catalyst activation energy. What is represented by the label X? Well, X represents activation energy, but this one is with catalyst. So activation energy, yes, activation energy is yes, alright, but with a catalyst. Ammonia is used to produce fertilizers. NPK fertilizers contains the element nitrogen, phosphorus, and potassium. Our fertilizer contains 22% phosphorus, 25% potassium. Draw a bar chart on figure 2 to show the percentage of phosphorus and of the potassium in this fertilizer. So the elements are to be represented at the bottom. So let's put phosphorus and 22. Then the next element is potassium, and potassium is 25%. So that's 25. Why do the percentage of phosphorus and of the potassium in this fertilizer not add up to 100%? Because the remainder of the fertilizers could be nitrogen. So there are other elements in the fertilizer besides phosphorus and potassium, and obviously there is nitrogen in the fertilizer since it is an NPK fertilizer. Fertilizers help plant grow by adding essential elements to soil. Table 1 shows the percentage of nitrogen, phosphorus, and potassium in fertilizers A, B, C, D. We can see the percentages. We can see that in A, there is no phosphorus present. In D, there is no phosphorus or potassium present. And in C, there is no potassium present. Plants lacking essential elements do not grow well because too little phosphorus can cause slow plant growth. Too little potassium can cause leaves too, which fertilizer helps prevent plant growth and brown leaf edges. So the plant must have phosphorus and the plant must have potassium. And along with that, the plant must need a nitrogen. So definitely it's going to be B because B contains all of them. Which fertilizer has the greatest total percentage of essential elements? So even in that case, the greatest total percentage of essential elements, the nitrogen, NPK, is in B. This question is about atmospheric pollution. Figure 3 shows limestone carving which has been damaged by atmospheric pollution. The carving has been done. The carving has been blackened by soot eroded where the limestone has reacted with atmospheric pollutant. What reacted with the limestone to cause the erosion? We know that acid rain is a big problem. So definitely should be acid rain. Soot is produced by incomplete combustion of diesel oil. Complete the sentences and choose words from the box. Incomplete combustion happens when there is not enough oxygen because oxygen is needed for burning. Incomplete combustion produces particles of, it produces carbon, which are like dust particles. Complete the sentence. Particles of soot in the atmosphere cause global dimming. Guys, for example, this question says if there is a release of methane gas, then we will say global warming, CO2, global warming. However, carbon dust particles causes global dimming, meaning that the sky is no longer that bright the way it should be. Carbon monoxide is produced by incomplete combustion of methane. That is the equation. There are 2 carbons in the left-hand side producing 2 carbon monoxide. Car engines work at high temperature, alright? In car engines, nitrogen is present. Nitrogen in car engine comes from the air, definitely. At high temperature, the nitrogen reacts with, definitely at high temperature, the nitrogen will react with oxygen in the air. The reaction will produce oxides of nitrogen. This question is about the rate of the reaction between hydrochloric acid and calcium carbonate. A student investigated the effect of changing the size of calcium carbonate lumps on the rate of this reaction. This is the method used. Pour hydrochloric acid into a conical flask to 50 cm cube line. Add 10 gram of calcium carbonate lumps to the conical flask. Attach a gas syringe to the conical flask. Measure the volume of gas produced every 20 seconds for 30 seconds. Repeat steps 1 to 4 using 10 grams of large calcium carbonate lumps. The student used 50 cm cube line on the conical flask to measure the volume of hydrochloric acid. Suggest a piece of equipment that the student could use to make the measurement of the volume more accurate. You see, measuring the conical flasks, the marking in conical flasks are not accurate at all. So definitely the student can benefit from using a measuring cylinder. Carbon dioxide gas is produced in the reaction between hydrochloric acid and calcium carbonate. Which test is used to identify carbon dioxide gas? Test for carbon dioxide gas is always lime water. So we will bubble it through lime water. Lime water turns milky. Table 2 shows the student's result for the large calcium carbonate lumps. You can see time in seconds and volume of gas in cm cube. Figure 4 shows the student's result for small calcium carbonate lumps. And we can see that at the time 80 seconds, the reaction has completed. Complete figure 4. Plot the data for large calcium carbonate lumps in table 2. Draw a line of best fit for large calcium lumps. Okay. Determine the mean rate of reaction using small calcium carbonate lumps between 0 seconds and 60 seconds. Mean rate of reaction, volume of gas produced, time taken. Because the question asked between 0 and 60 seconds. So let's find it out. Small calcium carbonate lumps. So 0 and 60, we'll extrapolate. So the mean rate of reaction can be calculated by the volume of gas produced, which is 48, divided by the time taken, which is 60 seconds. Describe what happens to the volume of gas collected using small calcium carbonate lumps between 0 and 20 seconds and between 0 and 80 seconds. So basically between 0 and 20 seconds, the volume of gas increases rapidly. Between 80 and 100 seconds, there is no change in volume of gas. The balance used to weigh 10 gram of calcium carbonate lumps caused an error. The balance always reads 0.2 gram before being used. What type of error was caused by the balance? So because it always reads 0.2 gram, that means it's a systematic error. Figure 5 shows the dimensions of two cubes of calcium carbonate. Small cube and the large cube. A cube of calcium carbonate has 6 faces. Calculate the total surface area of the large cube of calcium carbonate. Surface area of one side is equals to 2 times 2, which is equals to 4 mm square. So total surface area will be 4 times, there are 6 sides, so 24 mm square. The large cube of calcium carbonate was divided into 8 smaller cubes. The 8 smaller cubes have a greater total surface area than the one large cube. Compare the rate of the reaction when using 8 smaller cubes with the rate of reaction when using large. The rate of reaction of the 8 smaller cube is definitely going to be faster. This question is about ink. A student investigated green ink using paper chromatography in a beaker. The results the student obtained, measurements A, B, C, D, the student could make. So we can see the A, B, C, D. Okay. The students calculated the RF value of the blue dye. So we are calculating the RF value of the blue dye, this one. The student measured the distance moved by the blue dye is 2.7 centimeter, distance moved by the solvent 9 centimeter. So what is the RF value? In order to calculate RF value, it's very easy. We will always take the distance moved by our solute divided by the distance moved by the solvent. And when we're going to divide it, we're going to get our answer. The answer is always going to be less than 1. So in this case, 0.3. Which measurements on figure 6 are needed to calculate the RF value of blue dye? RF value of yellow dye. Okay. To calculate the RF value of yellow dye, definitely we require T, and definitely we require from the start line to the solvent front. So C and D. Paper chromatography has a stationary phase and a mobile phase. Draw one line for each phase to identify of that phase in the student's investigation. Mobile phase. So always the mobile phase will be the solvent because it is going to carry the ink, and the stationary phase is going to be the paper. The green ink contains 85% yellow dye and 15% blue dye. Determine the simplest whole number ratio of yellow dye is to blue dye in the green ink. Which word correctly describes the green ink? So let's see the green ink. The green ink is a mixture of blue and yellow. So thereby it's a mixture. So we can call it a formulation. The student repeated the investigation using green ink 75% and yellow dye 25%. What would happen to the RF value of the yellow dye? It will still remain the same because it's a pure substance. This question is about alloys. Bronze and brass are both alloys which contain copper. Bronze is an alloy of copper and one other metal. What is the other metal in bronze? So bronze is made from copper and zinc. Guys, at this point, this particular information is a little bit memorized information. Just remember the bronze is copper plus zinc. Give one use of brass. Now we know that brass in earlier times were used in making, ornaments, musical instruments. Alright, even buildings had roofs that were made out of brass. Okay, but in today's use, it will be ornaments and musical instruments mostly. So we will go with the safer bet. Alloys of gold are used to make jewelry. The proportion of gold in an alloy is measured in carats. Pure gold is 24 carat. 50% gold is 12 carat. Table 3 shows the information about two gold rings A and B. A and B contains only gold and silver. Suggest two reasons why the alloys of gold are used instead of pure gold to make jewelry. This is a very common question. If gold and silver is used in equal amount, then it will be 12 carat. And since this is 18 carat, so they will be used in different amounts. To answer for B, since 24 carat is the maximum amount of gold, so 18 carat will be divided by 24, which will give us an answer of 3 divided by 4. Since 3/4 is equals to 9, 1/3, 1/4 will be equals to 1/4 times 9 will be 3. So the answer will be 3 grams. Suggest two reasons why alloys of gold are used instead of pure gold to make jewelry. Alloys of gold are used, because it is much more cheaper, all right? And it is a little bit harder. And some people prefer to use alloys of gold because it looks better than pure gold. Steel are alloys of iron. Spoons are made of stainless steel. Spoons are washed after use, must not wear quickly, means it must not erode away quickly. Okay, good. Suggest one reason why stainless steel is suitable for making spoon. Because it contains a low amount of carbon in it, alright? So it's a low carbon steel, it's cheaper. Spoons are made of stainless steel. Spoons are washed after use and must not wear away quickly. Suggest one reason why stainless steel is suitable for making spoons. Stainless steel does not corrode very easily. Even if you were to use the stainless steel with a, let's say, dilute acid like ethanoic acid in vinegar, alright, it does not react with water and it's very hard. So we'll write one reason. Steel horseshoes are shaped to fit the feet of horses. Which type of steel is most easily shaped into shoe horses? So shoe horses are mostly made from low carbon steel because it is easily, the shape can be easily reformed. High carbon steel breaks and stainless steel is not used for making horseshoes. Alright guys, we're done with question number 5. We're done with this particular video. Thank you guys for joining this particular video. See you in the next video. Bye-bye.